the 737 MAX feels like a cursed plane. On the 5th of January 2024, the plane suffered yet another incident when a door plug in the fuselage of the plane ripped off at 16,000 feet. The force of decompression reportedly ripped the shirt off a child's back and slammed the locked cockpit door open. Searches for the missing door plug over the weekend only turned up iPhones, which somehow survived the fall to the streets of Portland below. Thankfully, none of the 171 passengers or 6 crew members on board were seriously injured, in part because the seats directly next to the damaged fuselage were empty. After cabin pressure was lost, the pilots dropped in altitude and returned for an emergency landing. So what exactly happened? How could an entire panel of an aircraft just rip off like this? To get some clues, let's first see what the hell a door plug even is. Door plugs are essentially structural and cosmetic covers for empty door frames. They are options for the 737-9 plane when an airline is purchasing the aircraft. If the customer wants a higher maximum occupancy, they can take the option to have a functional door installed in this door frame. This is because the number of passengers allowed in an aircraft is linked to how many emergency exits there are. If they chose for a lower occupancy, they can opt for a door plug, as Alaska Airways did. The door plug is not a functional door. It, as the name would suggest, simply plugs the doorway with a door-shaped plug. You can tell them apart from the outside as they have full-sized windows, where actual doors have smaller windows. On the inside of the plane, you can't tell that the door frame is there, as the panels look the same as any other panel. This allows a standard row of seats to be installed in this location. Deactivating this exit reduces the max occupancy of the 737-9 from 230 people to 189. If an airline later decides to increase the occupancy and operate more like a budget airline, like say Ryanair, where seats are placed closer together, they can later install a fully functional door in this location. It was this door plug that ripped out of the plane, and the photos of the aftermath are quite confusing. There was remarkably little damage to the plane. These are stop pads, and they are designed to take the load of pressurization from the cabin pressure, interfacing with the stop fittings on the door plug. Had the door been truly blown off, you would expect these to be damaged, but they look very much intact. Down here are hinges and straps that allow the door to open at about 15 degrees during maintenance. And at the top and bottom corners of the door plug are guide track roller pins that slide into guide tracks in the door frame, before being secured in place by locking bolts, one in each guide track. For the door to open, it would have to move downwards past these locking bolts. The door was found on Monday, 3 days after the incident, and it too seems to be in remarkably good shape. This to me suggests that either the fasteners attaching the plug to the aircraft fractured or they were improperly installed. Perhaps the incorrect bolt was used, they were under-tightened, or missing altogether. And indeed, early reports from industry insiders at United and Alaska Airlines are stating that they have found improperly tightened fasteners on several aircraft, which would make a lot of sense for how clean the brakes look. So, who's at fault here? It's of course too early to give a definitive answer, but the blame could well be spread across multiple parties. Boeing does not manufacture these parts themselves. Their subcontractor, Spirit Aerosystems, manufacture both the fuselages and door plugs in Wichita, Kansas, before delivering them by train for final assembly in Seattle, Washington. The door plugs are usually not rigidly installed in this step because Boeing removes them to install interiors for the final customer, and then fully secure the door plugs during reinstallation. This seems like the type of thing that could potentially get lost in communication between two separate companies. Perhaps in some cases the door plugs were never removed for this purpose, and whoever was in charge of reinstalling the doors was not aware that they were delivered in the semi-complete state. That's my working theory, but again, it's far too early to state anything with confidence. This is just me employing Murphy's Law. If something can go wrong, it will go wrong. Or perhaps someone somehow managed to not fully secure the bolts across multiple planes. That seems less likely to me. Boeing pressurizes the hulls to 150% of typical air pressure before delivering the plane as a safety check. So, in theory, this could have alerted them to improperly sealed door plugs. However, air pressure pushes the door plug against the door stops, and the semi-installed bolts could have held it in place during the test. But bolts can vibrate loose over time, especially if they are not installed correctly. That's why this wire tie is installed. It's designed to stop the fastener from rotating loose. There's a lot of different methods for doing this, like locking washers and adhesives. Some blame could also lay with Alaska Airlines. The initial National Transport Safety Report stated that that exact airplane had 3 previous pressurization issues where the pilots had to take action, all in close proximity to this accident on December 7th, January 3rd, and January 4th. And reportedly, the maintenance crew simply reset the pressure warning lights and system without performing any checks for pressure leaks, which could have been caused by this faulty door plug. Alaska Airlines knew there was an issue with this plane and decided to limit its operation over open water in case it turned into a larger issue with no emergency landing options nearby. So there appears to be some blame on Alaska Airlines and the regulations that allow them to simply turn off warning lights and assume that not flying over water will keep them safe. Someone could have easily died in this accident. It's a miracle no one near the door was pulled out during the rapid depressurization. However, most people are pointing the finger at Boeing. This is not the first time the 737 MAX has had issues. Some of you may be familiar with the 737's previous issues, where new, higher bypass engines were installed. Higher bypass engines are much larger and much more efficient, but Boeing had a problem. The 737 was too close to the ground, and they couldn't fit these new, higher efficiency engines under the wing without elongating the landing gear. So, they figured out a way of attaching the new engines higher on the wing to the point that the engine cowling is actually above the wing surface. This altered the stability and control of the aircraft, which caused the plane to be minorly unstable with a tendency for it to pitch upwards. A major redesign of the airframe to fix the issue would have required recertification of the aircraft and retraining for the pilots, a time-consuming and costly endeavour that Boeing's executives wanted to avoid. So, they installed a software instead that automatically adjusted the plane's control surfaces to compensate for the new instability, which they called MCAS, a software that malfunctioned, causing the plane to nosedive on several occasions. In some cases, pilots were able to identify the cause and turn off the malfunctioning system. But on 2 of those occasions, Ethiopian Airlines Flight 302 and Lion Air Flight 610, the malfunctions caused crashes, killing a total of 346 people. All 737 MAXs were grounded in the aftermath of the crashes. Boeing's then CEO, Dennis Muilenburg, was fired with a $62 million golden parachute. And Boeing paid $242 million in criminal fraud penalties, $1.77 billion in damages to airline customers, and $500 million to the victims of the crashes. These crashes deservedly damaged Boeing's reputation, showing that their executives were willing to take shortcuts to increase revenue. Although the severity of the issue is clearly not on the same scale, many are joining the dots and seeing a pattern with Boeing's business practices over the past decade. Boeing recently requested that the FAA exempt the 737 MAX 7 from a safety regulation so they could deliver planes on time as they worked on a long-term solution to an overheating problem with the engine. A problem which they asked the pilots to solve by limiting their use of the anti-ice system to just 5 minutes when flying in dry conditions, because the inlets around the engines get too hot and could fracture and strike the windows and cause a rapid decompression. Just like what happened to Southwest Flight 1380 when a 737NG suffered that exact fate, and a passenger was partially ejected from the plane and died as a result of her injuries. This was an older plane which is not affected by this overheating issue, which is caused by the composite material cowlings, which is an issue exclusive to the 737 MAX, but the potential loss of life is the same. To the recommendation of limiting anti-icing system operation to just 5 minutes, a representative of American Airlines pilots said, "We're not interested in seeing exemptions and accommodations that depend on human memory. There's just got to be a better way." Loose bolts across multiple planes is a sign of a systemic issue once again. something that should be easy to add to a checklist and have a quality assurance inspector check it. However, in 2019, Boeing began laying off quality assurance inspectors in favor of so-called verification optimization, using less staff and more technology solutions. Reportedly, 900 inspectors were laid off over 2 years, a decision the Boeing Workers Union said was short-sighted without considering the long-term consequences. It turns out, it didn't take that long to see the consequences. Thankfully, no one died on this occasion, and it should be an easy issue to fix, but it just shines another light on Boeing's recent company culture. People claim this change in attitude is due to business executives leading an engineering company, but honestly, I think that's just self-congratulatory nonsense from engineers. Dennis Muhlenberg, the CEO during the 737 MAX crashes, was an engineer by training. Business majors do not have a monopoly on corporate greed. Engineers are perfectly capable of it too. Boeing has amazing engineers and produces amazing products. I have made an entire video gushing over the masterclass of design that is the 787. But there has been a systemic issue of prioritizing revenue and executive paychecks over customer safety and employee job security. I think it's fair to say that a company with this much risk and responsibility over public safety needs more regulatory oversight, and asking for an exemption from a safety standard is a pretty clear sign that even the regulations that are in place are not being respected.